Okay, so y-intercept for any graph, it's where the graph crosses the y-axis. Okay, where the graph crosses or touches the y-axis. And it doesn't matter whether it's a parabola, any kind of a graph. It doesn't matter the type of graph. If you are crossing or touching the x-axis, the x-coordinate of that point has to be 0. So algebraically, if you don't have a picture of the graph, you can find the y-intercept just by simply plugging in 0 for x. So I'm just going to, and you don't have to draw this, I'm just going to draw like tiny little graph to the side. So let's say we have our parabola, and I'm just going to sketch something. Where it touches or crosses the y-axis, that's your y-intercept. And the reason it's x equals 0 is because the equation of the y-axis, it's a nice vertexal line where all the x-coordinates are 0 up and down the y-axis. So I know if I'm interacting with the y-axis, the x-coordinate of that point has to be 0. The y-coordinate could also be 0 if your graph goes through the origin maybe, so that doesn't, it's not that y can't be 0, but most of the time y is some number other than 0. Okay, so if you have a graph in standard form, which I do just to the side here, does anybody know, just like without doing anything, what the y-intercept of this graph would be? 0, 13, for sure. And the reason it's easy to see in standard form, if I would just sub in 0 for x, you guys don't have to write this, I'm just going to write it real quick, but what happens when I plug in, I don't know, I just wrote 5, okay, 6 times 0 plus 13, that 0 multiplied by 0 and that term multiplied by 0 and that term, it just wipes out both terms that have variables in any quadratic that's in standard form and leaves you with the constant term, which is the plain number on the end. Just remember though, like if I say what's the y-intercept, don't just say 13 because you're talking about the point on the graph. You're plugging in 0 for x and it's going to be the point 0, 13 if we were looking at that visually. Okay, now it's different. You cannot see the y-intercept unless maybe you're a genius or something, but you can't just look at the equation in vertex form and just see the y-intercept. You kind of have to find it or think through it. So you can see the vertex in vertex form. Can anybody tell me the vertex for my first example that I have typed out in example 1? Like what would the vertex be? Jonathan would think -5, 3. Just your opposite copy. Now, how would you, I had people like on the quiz, they just wrote down that 3 was their y-intercept, but that's not true. How would I find the y-intercept if I have vertex form? Rudy, what do you think? Or no?
You would need to turn it into standard form and then plug in 0 for x.
I could do that. We could. Do we want to multiply that out in standard form? We can. Would there? We could. You know how you said you could plug in 0? You could just plug in 0 to that form. Yeah, you could just do that right there. I was just trying to save you a little bit of time. If you want, actually, if you did multiply it out, whatever the constant term is should be your y-intercept. But if you have vertex form, if you don't want to multiply it out, you can actually just plug in 0 right there. And that might just save you a little bit of time. You can always multiply it all the way out and get standard form, find the constant term. Or if this is a little bit faster for you, just plug in 0 everywhere you see an x. Now, in the little parentheses there, 0 plus anything is just that thing. So that just becomes 5 squared. Don't forget the squared on this because that's what people will do sometimes. Guys, let's put the computers away. The typing is distracting me. Okay, so if I square 5, I'm going to get 25 plus 3. So I'm going to get 28. And then remember, that 28 is the y-coordinate of that y-intercept. So the actual point where the graph would go through the y-axis would be 0, 28. So that would probably not be something I would ask you to graph because that would have to be a humongous graph. Okay, what about the vertex for this second example I have here? What would you tell me the vertex is? What would the vertex be? Excellent, 3, 6. And then again, if you want to go ahead and like FOIL this out, multiply it, put it in standard form, you could do that. But if you just need the y-intercept, it might be just a teeny tiny bit faster to just go ahead and plug in 0 for x. You got to do a little algebra with that. but it might be a little bit faster than having to FOIL and all that other stuff. Now, most common mistake, the previous question we just did, I didn't have anything in front of the parentheses. It would just have a 1 in front of it. The most common mistake I'll see people make, if you want to just type this in your calculator, it shouldn't be a problem. If you type it just exactly like I wrote it with the parentheses and everything. But the most common mistake I'll see people do if they do this by hand, they'll do like -2 times 3, and then they will square that. Don't do that though, because in your order of operations, you have to do that power before you do that multiplication. So first thing I should do if I'm doing this by hand is square the -3, which will make +9 instead of that -3 squared to simplify that. Then go back and multiply it by the -2. So this would be -18. And I'm just dragging down that +6 with it. So ultimately this would be -12. So then my y-intercept there, again, the y-coordinate is what you're getting when you solve for that because you plugged in 0 for x, so the actual point is 0, -12. Is anybody having a question about that? Okay, now we're going to practice another little algebra skill today with writing an equation in vertex form, given just a little bit of information. And I will tell you, I have been doing this in the resource room with the pre-calc table for the last 2 weeks because they forgot how to do this. So I'm going to go through this with you guys. This is not hard, but it's a little bit of organizing your steps, and it uses some algebra. So when you have vertex form, you can see the vertex right away from that form, and you can also see the a value from that form. You can write an equation with only these 2 pieces of information if they give you a vertex, and it has to be the vertex and then any other point on the graph. So the vertex, if you remember, would just be h and k in that formula. So if I know the vertex, I already know h and k. If I don't know anything else other than this point they gave me, I can use that to find a. A will be the only variable. What you would do with that point is plug it in for the x and the y. Now, at the very end of this, we're going to have to go back in and plug in the vertex and the a value, and we'll have x and y in our formula. But if they give you a point, you can plug that point in for x and y in that equation and use that to solve for a. Now, it's super important. You have to put the vertex in for the h and k, and you have to put the point in for the x and y. If you mix that up, you will not get the correct a value. So if I'm writing this out, here, don't write this, it's in the middle of the page right there. I'm just going to kind of show you how I'm plugging it in. So for y, I'm going to grab the y coordinate of the point, which is 9. A, you won't know, so that'll be your variable here. X, you're going to grab the x coordinate of the point, which is 3. And then it's minus the x coordinate of the vertex, which is 5. So it does look like a -5 there. Remember, I always tell you guys it's the opposite of what it looks like. So that would look like a -5 in the formula almost. And then the y coordinate of the vertex is k. That goes outside the parentheses. If it's positive, you put a plus. If it's negative, you put a minus. So I'm going to put +7. Okay, we're just going to simplify this a little bit. So subtract here. Don't try to distribute the exponent. Just like subtract, like 3 minus 5. So this is -2 squared plus 7. And what do I get if I square -2? What do you think? 4. All right, so this would be, I'm going to write this just so the 4 is in front of this. This would be 4 times a, because I'm doing a times that -2 squared. I'm just going to put the 4 in front, plus 7. We're just solving this tiny little equation. So I'm going to subtract 7. This is going to be 2 equals 4a. What is your a value going to be here? What do you think? 0.5. Yeah, be careful. Sometimes people just see the 4 and the 2 and they think, oh, 2. But actually to get the a by itself here, you would divide by the 4. So just be careful with that. So a should be 0.5 or 1/2, either way. Now, the actual answer to the question, you have to kind of back up and put that information into the vertex form. In the actual vertex form, you should see a y and an x, because that's going to relate your equation there. So we're going to do y equals, I need a number in place of a, that would be the 1/2 we just solved for, and then parentheses x. You need a y and an x here. We're going to plug in the vertex, but we already have the vertex. So h is 5, so it's going to look like a -5. And don't forget the squared, because if you don't have the squared, you don't have a quadratic. So it's x minus 5, that's squared. And then on the outside, the y coordinate of the vertex was 7. So in vertex form, that would be the equation of the parabola that has that vertex that goes through that point. Is anybody having a question? Okay, just want to practice this with you one more time. So if you know a vertex, I got for this example -4, -8, that has to be your H and K, and you know a point. You can plug that in for X and Y in that formula for vertex form. The only thing you won't know is A. Okay, can anybody just raise your hand and tell me, like, what would you write out as your first step if you plugged in all the information that you have there? Jonathan, you go ahead. Perfect. And if you guys want to go, like he said, minus a negative, that is going to look like, if I simplify that just a little bit, minus a negative turns into a plus. And remember what we've been saying, the x-coordinate of that vertex is -4. It's going to look like a +4 in the actual formula. Now, this guy, I have 0 plus 4 is just 4. So we're just going to have to move the 8 and square the 4. So 4 squared is 16. And so I've got 16a minus 8 equals 40. We're just going to solve this little bitty equation. So we'll add 8. We get 48 equals 16 times a. Anybody know what a is there? It's a nice number. Can't read it. Yes, ma'am. All right, now, you got to remember, I'm not done. Like, it's not to find a, it's to write the equation. So I got to go back and plug all this into the equation. So y equals, in place of a, I'm going to put a 3 right in front of the parentheses, and then you need an x and a y here. It should be x plus 4 squared. Don't forget the squared, because if you don't have a squared, you don't have a quadratic. And then the y coordinate was -8, so it just would have a -8 outside the parentheses. So you should be able to see the vertex from the equation and the a value. We're using that point they gave us to help us find a, because they don't tell us that initially. Is anybody having a question? Okay, now I'm going to give you kind of the same question, but I'm going to give you different information here. So I'm going to give you a picture of a graph. And I'm going to ask you to do the same thing. And forgive, let me just write the vertex form one more time so you guys can see it. You don't have to write this. I'm just going to ask you to write me the equation, just like we did on the other side. Write the equation of this parabola in vertex form. I'm just giving you different information here. I'm going to give you a picture. Okay, what can you get from the picture that would help you do this? Riley, what do you think? The vertex. Okay, what's your vertex? Perfect. There's your H and K. Then what else did you say? A point. Okay. Any point. Any point. Yeah, just look for something. And there's, honestly, on this graph, there's really only 2 options that go right through a corner. But you need the vertex, and then you can grab the point from the graph. 2, 0, or 4, 0 on that particular diagram are the only 2 places that go right through a nice corner, and we can identify that point. Okay, now I'm going to ask you a question. Can anybody tell me the a value by looking at the graph? It's -4. Okay, definitely. Now, you might not be able to tell, you might be like, what the heck? If you have a picture of a graph, if you go over 1 and then go to the next point here, this is over 1 down 4, that will be your a value. You might be able to just figure it out from the graph, because if you guys think about this, like if my a value is 1, right, the pattern is 1, 3, 5. If my a value is 2, the pattern is 2, 6, 10. So that first step when you go over 1, if you did 3, it'd be 3, 9, 15, and this one is 4. So if you did 4, I don't feel like we've done a 4, but it would be 4 times the 1, 3, 5, so it'd be 4, 12, 20. But anyway, if it's a nice number, if you go over 1 and that next value as you go up or down is a nice and on a nice point, you might be able to figure out the A value without doing that process that we did on the front. If it's a fraction or something, that can be a little trickier. So I can see the A value and make sure it's negative because it's going down. If you want to stop right there and you go, okay, I got the vertex, I can figure out the A value from the graph, just write your equation. So this would be -4 x minus 3 squared plus 4 would be our equation. If you're like, Ms. Grody, I totally could not tell that the A value was -4. That is completely fine. You can just do the process that we did on the front, grab one of those points, like maybe I would grab the 2, 0 real quick, and we could do the same process. I'll do 0 equals A times, let's see, 2 minus 3 squared plus 4. And then we could just solve it from here. So this would be A times -1 squared plus 4. Let me move that 4 to the other side. And if you square -1, that would then just be 1. So you can get your A value algebraically, but sometimes if you have a picture of a graph, you might be able to just figure out the A value by looking at the graph. So it's totally up to you. If you don't see the A value, if that's hard, just do what we did on the front. Can anybody tell me the A value for this second graph without doing the process we did on the front? What do you think? It's 1/3. Yes. Okay, now I'll show you guys this. If it's a nice fraction, like a 1/2 or a 1/3, if the top of the fraction, the numerator is 1. If you wanted to try and figure this out from the graph. Okay, I'm going to grab the 2 nicest points I can find. So from the vertex, there's a point here, there's a point here. This goes over 3 and then up 3. If those two are the same, like if they're 2 and 2 or 3 and 3, that will be 1/3. If it was 2 and 2, it would be 1/2. If it was 4 and 4, it'd be 1/4. If you have a little bit weirder fraction, like if you had like 2/3 or something like that, you might need to do the process we did on the front. But you can figure these out sometimes from the graph if you want to save yourself a little time if you have the graph. If you don't want to do that, on the front, all you'd have to do, grab your vertex. This is 2, -1, so that's your HK. And then you just need another point. I just gave us 2 options that went right through a corner on the graph there. So either one of those, let me do the 5, 2, and you could plug it in for X and Y and just do the algebra. So it's totally up to you. It'd be Y coordinate of the point equals A times X coordinate of the point minus X coordinate of the vertex squared. And then in this case, it'd be minus K because the K is -1. You could also use this to find your vertex, or sorry, not your vertex, sorry, your A value, and then plug it back in. But you might be able to tell from the graph. So if you can tell from the graph, you just ignore what I'm doing right now. I'm going to add 1 here. You'd get 3 equals A times 3 squared would be 9, and then you divide by 9. And 3 divided by 9 is going to reduce to 1/3. So it's, if you can get it from the graph, that's awesome. If you can't see it from the graph, you can do the algebra every time, and to get the actual equation we have to plug that information back in. So this guy'd be 1/3, let's see, x minus 2 squared minus 1. That would be the actual equation there. But if you have the graph, you might be able to figure out the A value without doing all that algebra. Is anybody having a question? Okay, I want to practice this one more time. So this is going to ask you to go ahead and put the equation in standard form to just practice. I had some people kind of mess this up on the quiz too, so I'm going to go over this with you guys again. If you are going to take these 2 equations, I'm just going to rewrite the equation from part A and from part B, and we're going to write these in standard form here real quick. Okay, now just remember, major thing. If you are squaring something, do not distribute that exponent in there. If you have adding or subtracting, you will miss the middle term. If you square something, you are multiplying it by itself. So I'm just going to write x minus 3 twice, so I don't forget to do that to get the middle term that I will miss if I try to distribute that exponent. That's not correct. Now, the other thing I saw people kind of mess up, you only want to distribute that -4 to whatever you get when you do a foil or box with this quadratic. So just be careful with that. It's my recommendation to go ahead, foil or box those two sets of parentheses, and then go through and distribute whatever the a value is. For this question, it's -4. Okay, now I'm going to write this out real quick. If I did foil or box, either way, you'd get x squared, then you would get minus 3x, then you would get another minus 3x, and then -3 times -3 is 9. Don't forget the +4 that was on the end of that. Now, I had somebody last period just say, hey, because they could kind of figure out they get -3x, so they said, hey, could I just write x squared minus 6x plus 9? Would you take off points for that? No, I would never take off. If you can do this kind of quickly in your head, skip that step. That's totally fine. I do that all the time. But if you need to, you can FOIL it out or use a box. I'm just trying to show you where that comes from. But if you understand that, you can skip that step. You go right ahead. You only distribute the a value to whatever you got when you multiplied out that quadratic. So I'd get -4x squared, then it'd be plus 24x minus 36. And then don't forget to bring down that 4. Should be one more step because you can combine the constant from the quadratic and that plane 4 that we had on the outside. So you get totally done. -4x squared plus 24x, -36, and 4 is -32. Now, I could have gotten the y-intercept just from my vertex form by plugging in 0. If you have it in standard form, it's a little bit easier to see. So we already had to do all that work. Your y-intercept should just be 0, whatever the constant term is, which for this question is -32. Okay, now I'm going to do one more with the fraction here. So with the fraction, we've got an a value that's 1/3. Again, don't forget if you're squaring something, you're multiplying it by itself. So if you like FOIL or box, go for it. And if you understand, like, okay, I'm going to get x squared minus 2x, and you want to just write -4x, perfect. Be careful with these negatives though. -2 times -2 for the constant term should be +4. So don't forget that. Now, if you're working with the fraction and you're doing this by hand, I'm just going to write 1/3 x squared. If you do a fraction times a number, you just do the numerator times the number. So 4 or -4 times 1, I'd write -4, put the denominator underneath. So 1/3 times -4 would just be -4/3. -1/3 times the +4 is going to look super similar. So I'm going to just have 4/3. And then I have this -1. Okay, now I'm going to ask you a little question. Can you think of a number that if you divided it by 3, you would get 1? 3. So the reason I asked you that question, I'm going to rewrite this -1 as -3/3. That way I have a common denominator between my constant term and what I had there, that -1, because they're both fractions. You got to have a common denominator. Just makes it a little easier to work with. So then we're just going to combine all our like terms. We'd have 1/3 x squared minus 4/3 x, and then 4/3 minus 3/3 would be 1/3. And let me just pull this down just for, see if I can pull this graph down just for a second. If you look back, here's the second graph, right? If you look at the y-intercept, you can see that's not on a nice point. So me getting 1/3 there, that makes sense. You couldn't see the y-intercept on the graph above that to compare it, but in this case, your y-intercept would be 0 and then 1/3. Is it a question? If you want to, yeah, if you wanted to put 0.3 repeating, that's the same thing as 1/3. Okay, now I don't normally do this, but I just want to see. I have just a couple graphs on this page here. I just want to see if you guys could figure out the a value just from looking at the graph, just real quick. And if you can't, that's okay. We could grab a point and a vertex. I just want to see if you can kind of use this. And please forgive, I don't know why the grid marks did not show up very well on these first 3 graphs for some reason, but could you just look at that and see if you could figure out the a value? So if I look at the first graph, can anybody tell just from looking at the graph what the a value should be? What do you think? You're close. It's not 2. What do you think it is? It's 1. It's so hard. Sorry, you guys. It's so hard to see these. If this first point from the vertex goes through a nice point. This is over 1, up 1, then your A value is just 1. I need to redo these graphs. What about, can anybody tell for the second one? This is negative 1. So if you go right from the vertex, you're going over 1, down 1. So negative 1. Can anybody tell for the third graph I got here? Ethan, would you? Yes, this one's negative 2. If you go from the vertex to get to the next nice point, it goes over 1, down 2. So if you go over 1, up or down a number, that's going to be your A value. Now, this one is a little trickier. Can anybody tell the A value for this question? What'd you get? This one should be 1/2. Yes, definitely. Okay, now if you do have a fraction, if it's like 1/2, 1/3, if you go from the vertex to the next nice point on either side here, this is over 2, up 2 to get to that. If those are the same, that'll be the denominator of the A value, just be 1 over that. If you can't tell that though, again, you can always just grab the vertex and a point and do the algebra. Can you guys tell for this graph in the middle of the bottom here? What'd you put? This one should be 3. So if you can figure that out from the graph, you're going over 1, up 3 as your first step. So that has to be your A value. This last one's really tricky today. Oh, Hunter, did you get this one? This is 1/4, but it's just because it's turned upside down, I'm just going to put a negative in front of it. This is really tricky to see, but if I go to get to my next nice point, it's like all the way over here. So I'm going over 4 and down 4. So if that's the same number, it's going to be that'll be the denominator. Just put a 1 on the top. And again, if you don't like that, if you can't do that, that's fine. Just grab the vertex, grab the point, and you can do the algebra that we did in those other examples. That will always work if you can find a nice point. Is anybody having a question?